So sample 2, paper 2, we're on question 6, okay? Draw a square OABC of side 6.5 units on the grid below. So what we need to do is we need to mark out our grid according to numbers, so it goes 1 to 7 basically. And what we need to do is going to mark out 6.5 on both grids. So we can see 6.5 here and 6.5 down there. What we're going to do is we're going to draw a line coming across from both 6.5s, and where they intersect is basically the box, okay? So we can see that we've drawn the black square here of 6.5 units long. Now on the same grid, draw an image OABC under the enlargement with center O and scale factor 0.4. Now, what does a scale factor actually mean? Scale factor of 0.4 means it's actually going to be a smaller image. An example would be if I had a square of length 4 and width 4 and I said the scale factor was 2. This would result in a square of 8 by 8. So currently we have a square of 6.5 by 6.5. This is going to result in being multiplied by 0.4 to make it smaller. When we multiply that by 0.4, what we're going to get is 2.6. So the square is now 2.6 units wide and long. So therefore we go 2.6 up on the x and y axis and draw our red square here. So now we can see the image of the new square over the old square. Now find the area of this image. Now the area of this square is basically its length by width. It's going to be 2.6 multiplied by 2.6. Okay? And 2.6 multiplied by 2.6 is 6.76 square units, or units squared. So we'll just verify this. 2.6 multiplied by 2.6, that gets you 6.76. Okay, now under the enlargement of the image OABC, under the same enlargement is a square with area 95.0627 units squared. Find the scale factor. So what we had to remember about scale factor, if I can just get up here. Okay, so this is our old square, 6.5 by 6.5. It's 42.25 meters wide, alright? And what we have next is basically, that's the old area, is 6.5 multiplied by 6.5 is 42.25. That's the old area. The new area is 95.0625. So k squared, or the scale factor squared, tells me how much bigger my area is. Okay? The normal k tells me how much bigger my length is, but k squared tells me how much bigger my area is. Okay? So what I can do next is I can divide one area by the other area. So I can divide my new area divided by my old area, and this will tell me what k squared is. So put that into the calculator. Put in 95.0625 divided by 42.25, and what that will tell me is that k squared is 9 over 4. Therefore k equals the square root of 9 over 4. K is going to be equal to 3 over 2. Okay. Now another way of doing this would have been just to write down your square as it was at the start. Say that its length is x and its width is x. Therefore x squared equals 95.625, because area equals length by width. Length by width is x multiplied by x, which is x squared. Therefore x squared, x will be the square root of 95.0625. So if you were to put down the square root, 95.60625, and what you get is 39.4 or 9.75. Okay, then we can say x is 9.7275, and then we can say the scale factor is new length divided by original length, which is 6.75 divided by 6.5, which is also 3.2. So either way you get the same scale factor. Now a triangle ABC has sides length of AB is 6 centimeters, length of BC is 2 centimeters, and length of AC is 3 centimeters. Evaluate AB plus BC. Just add them together. 6 plus 2 is 8. Evaluate AB plus AC. 6 plus 3 is going to be 9 centimeters. Evaluate BC plus AC. It's going to be 2 plus 3, which is going to be 5 centimeters. Attempt a sketch of the triangle in the space below using AB as a base. Using compass and a ruler, explain why you cannot draw this triangle. So, imagine I had a normal triangle. I'm going to explain how we draw a normal triangle. 5 centimeters is the base. Okay, so here's our 5 centimeters now. Just maneuver it around so we get the right area on it. So there it is, there are 5 centimeters. Draw a 5 centimeter length as shown. Then come down with your compass, measure out your 4 centimeters. Once you've measured out your 4 centimeters, go to the corner and draw out an arc. Then measure out your 3 centimeters. 3 centimeters as shown. And then measure up your 3 centimeters, draw a second arc. Then draw the 2 lines. Draw a line from each corner where it meets, and you end up drawing your triangle. Now in this case we actually can't seem to draw the triangle because the following lengths, there's different lengths involved. AB is 6 centimeters, BC is 2 centimeters, and AC is 3 centimeters. So we're just going to draw this out. 6 centimeters for AB. Then we're going to come down with our compass and we're going to find out where 3 centimeters is. There's the 3 centimeter mark for AC, which is over here. And then we're going to draw an arc going up from A to C all the way across. Then we're going to do the same thing for point B, where it's 2 centimeters long. As you can see here, it's now 2 centimeters long. We're going to go over to point B, draw another arc, and what happens here is that you can see that there's no intersection this time. Therefore, I can't seem to draw the triangle. So no intersection of arcs. AB plus BC is less than, this is the less than sign, is less than AB. This is a problem. I basically can't draw a triangle. If I have one length is 3, the other length is 2, and the other length is 6, this is an impossible triangle to draw because 3 plus 2 is smaller than 6. Okay. If BC is increasing length to 3 centimeters, would you be able to draw the triangle now? Explain why you still cannot draw the triangle, stating the term you're using explanation. Here's a 6 centimeter line. Here's a two 3 centimeter lines. The two 3 centimeter lines, when combined, only equal the 6 centimeter line. This means when you join them, it'll just be a straight line. No, because AC plus BC is not greater than AB. So not greater than. So if you actually want to draw a triangle, the key thing about drawing a triangle is that the two sides, 4 and 3, have to be bigger than 6. When you add two sides together, they must be bigger than the third side. So that's what the rule is there. Okay, so their theorem: the sums of the lengths of any two sides of a triangle must be greater than the length of the third side. Okay. Next one, question 7. This bar chart shows the outcome test performed on 300 water supplies for possible pollution in a given year. Cryptosporidium, bromate, aluminium, E. coli, turbidity exceeded, THMs and nitrate. Now, given that some water supplies were affected with more than one pollutant, find the maximum number of supplies that could have been polluted. The maximum number of supplies that could have been polluted was basically if they only had one each. That each one was affected with one each. So we're going to add all these together and assume that there's no double counting. Okay, so we're going to use our graph to calculate each one. So that's going to be 72, 9, 22. This one's 67. This one's 12. This is 45, and that's 8. Going to add them all together now. And we get is 72 plus 9 plus 22 plus 67 plus 12 plus 45 plus 8 is 233. So this means that there's possibility of 233 of the water supplies actually being affected. So this is 235 of the public water supplies are affected. Now, what percentage of supplies were polluted with at least cryptosporidium. So cryptosporidium is 72 out of the 300 waters, multiplied by 100 over 1 to turn it into percentage mode. That equals 24%. Why is a bar chart more suitable than a column graph here? What a column graph is basically the bar charts being horizontal. And what we'd have to do is we'd have to label all the pollutants underneath here. Now this doesn't really suit because we can see that the pollutant names are quite long. So by having them aligned in this manner, we were able to fit in the names of the pollutants quite easily. So therefore, you can see that the length of the pollutants is quite long, okay? So this wouldn't have fitted into the vertical bar chart, so we can see here it would have been quite hard. So the name of the pollutants are quite large, making them difficult to fill in the horizontal x-axis of a normal bar chart. Okay. In a sample of 100 supplies, 50 were polluted by cryptosporidium, 38 were polluted with E. coli, and 20 were unpolluted. Use a Venn diagram to find out how many were polluted with both. So we can start off with the 20 on the outside, which weren't affected at all. When we add up everything, it has to add up to 100 supplies. X is what we're looking for. We're looking for how many were polluted with both. If X of them were polluted with both, this means that 50 minus X were polluted with cryptosporidium only, and this means that 38 minus X were polluted with E. coli only. When we add all these zones together, they must add up to 100. So 20 plus 50 minus X plus 38 minus X must equal 100. Therefore, we can add them all together, cancel off the X's, and then we're left with 1 minus X. 20 plus 50 plus 38 is 108. 108 minus X is 100. This means X is equal to 8. Okay. Now that we can fill this back in, X is 8. The E. coli only is 30. And cryptosporidium only is 42. Okay. Now, using the sample of 100, what's the probability the supply was polluted with both? Polluted with both was 8 out of 100. So it's going to be 8 out of 100, which is the same as 0.08, which is the same as 8%, which is also the same as 2 out of 25 in fraction mode. Polluted with E. coli only. Okay, so E. coli only. We can see that E. coli only was 30. So that's going to be 30 out of 100, which is 30%, or 0.3 in decimal form, or 3 out of 10 in fraction form. If 3 suppliers were visited by an inspector, what's the probability that he would find all 3 of them polluted with cryptosporidium and E. coli using the data from part E? So we have to get 3 in a row, so there's a 2 in 25 chance that it has both cryptosporidium and E. coli. If this were to happen 3 times, the probability gets multiplied by itself 3 times to see, like, the odds on this happening are very low. So the odds of it happening 3 times in a row are even lower. So this would be 8 out divided by 15,625. Next question. The Environmental Protection Agency is responsible for monitoring quality of drinking water in Ireland. In 2010 report, it produced following trend graph. In monitoring the safety of public water supplies 945 supplies were tested each year. Now, what we can see is that we can just label all the numbers of each graph. Okay, so we can see that in 2004 there's 91 tested positive for E. coli, and in 2010 we see that only 20 tested positive for E. coli. Find the percentage of the supplies tested in 2010 which had E. coli. So in 2010 there was 20 out of 945 water supplies had E. coli. Multiply this by 100 over 1, and what you're going to get is 2.116%, or 2.12% had E. coli. Okay. Now find the percentage of decrease in pollutant supplies from 2004 to 2010. Now in 2004, 91 out of the 945 water supplies had E. coli. Multiply this by 100 over 1, and what we get is 9.63%. Now we want the difference between 2010 and 2004. So take away 9.63% minus 2.12%, And what we'll get here is 7.51% reduction. In private water supplies, the percentage of water supplies affected in 2010 was 11.6%. Can you make a comparison about private versus public water supplies? Well, private water supplies 11.6, public water supplies was 2.12. Basically, the private water supplies are far inferior when it comes to basically pollutant control. So they have inferior rates of pollution. Okay, means higher rates of pollution are inferior. You want smaller rates of pollution. The bar chart below shows the number of E. coli report failures in public water supplies in 2010 by cause. Draw up a pie chart to illustrate this information. So what we have here is 13, 4, 7, 7, 13, and 2. What we need to do is we need to add them all up together, and what we find out is it's 46 different problems. Okay? Now we need to convert this into fraction mode. 13 out of 46 was inadequate treatment, 4 out of 46 was contamination, 7 out of 46 was plumbing, 7 out of 46 was distribution, and 13 out of 46 was chlorination, and 2 out of 46 was others. In order to convert these into angles, we need to multiply everything by 360. Okay, so we're going to make our list of each one, and we're going to multiply them all by 360. Okay, so multiply 13 out of 46 by 360, we get 102. Okay, we also get 102 for chlorination. Contamination is going to be 4 divided by 46 multiplied by 360, and I'll just quickly show you this now. So 4 divided by 46 multiplied by 360, and what that will get you is 31.3. So we're going to round down to 31 degrees for that one. Okay, so it's 31 degrees for the contamination, 55 degrees for the plumbing, and distribution will be another 55 degrees, and the others will be 16 degrees. However, when you add all these up together, you're going to get 361 degrees, so please just be careful regarding your decimal placing. Okay, next thing we got to do is we actually have to go about drawing this. We're going to use the protractor here. The protractor is going to be set to the protractor here is going to be set to 100, and we're going to set it to 102 degrees. Okay, so here we go here. Let's go at the start. So we need to set this to 102 degrees, which is here. And then we're going to mark it where the 102 degrees is. So just going to mark it with the red black pen here. Okay, so just want to rub out a little bit, just the parts that we don't need. Okay, so that's pretty inaccurate, so we need to okay. So we're just going to make this protractor a bit smaller. Okay, so what we can see here is that if we were to draw this, okay, so we can say that the marking here is 102. 102, so we can just draw the line up around here. Okay, and now what we got to do is we got to mark that in. So we're just going to draw the ruler up here, and this is inadequate treatment. Okay, inadequate treatment. So just going to label that treatment. Now, next thing we're going to do is we're going to do another 102 one while we're here, because it's already made for us. Okay, so what we can just do is we can just rotate this around. we can turn it upside down, and we can go for another 102. Okay, so 102 here would be, that's 90 degrees. So 102 should be 78 around there. Okay, so that's another 102 degrees. See, so it goes 9, 10, all the way up to 102 degrees. Just going to quickly mark off a little part of it there. Drag this away. And we're going to make sure that our line goes through the center of that. And there is our chlorination. Okay. Now, next one we gotta do is our 55. We can do our 31 degree contamination. Okay. So we'll just make this a bit bigger. 31 degree contamination. So we're just gonna line up the protractor with the last straight line we had here. So you can see it's lined up pretty well. And now we're going to try and get it at 31 degrees, okay? Or 31 degrees being 159 if you take it away from that. So that's 31. 149 degrees. So that'd be our 31 degree angle there, okay? So we're just going to mark this off there. And this line here will be our... This line here is going to be our contamination, okay? So contamination. So there's our contamination, okay? So we have this one, this one, this one. Now we're looking for our 15 degrees, or sorry, our 55 degrees for the next one. Just going to rotate around again. Okay, so now we're going to go for our 55 degrees. Okay, so 55 degrees would be around here. We can just put a little mark in there. And once again, just draw it from the center all the way through. And this one here is plumbing. Plumbing. And then finally, another 55 degree one. So another 55 degrees will put us here. And then to the center, and there we go. So that's going to be plumbing and distribution. And finally the last one is other. Okay, so there's our diagram there. Okay. Now, the graph below shows the frequency distribution or percentage contamination in 100 grams of beef burger. Okay. Now, comment on the shape of the distribution for frozen and fresh beef burgers. Explain what the graph means in terms of comparing how safe it is to eat fresh over frozen beef burgers. Okay. So the frozen beef burgers, we can see they have a normal distribution, okay? So it's quite a normal distribution, okay? So frozen beef burgers have a normal distribution. Normal distribution, much safer to eat with lower levels of contamination. Now let's have a look at this, right, and verify what we're seeing, right? So we're seeing that the percentage of contamination of beef burgers, okay? We can see that it has a much smaller area than the fresh beef burgers. Okay, so we can see that the green area is less than the red area. Okay. So we can see that the fresh beef burgers have a higher amount of contamination than the frozen beef burgers. Okay. Okay. And the next question. Fresh beef burgers are positively skewed, so we can see that there's a positive skew. The tail is going towards the end, so there's a positive skew on the distribution of the uh, the fresh beef burgers. Okay, so fresh beef burgers are positively skewed. Positive skewed. Not as safe as the frozen beef burgers. Due to much higher levels of contamination. So what we can see in this graph is that they both have a low amount of 1% contamination of the burger. The frozen has a much higher of 2% contamination and 3% contamination. But after 3% of contamination, only the fresh burger has a higher amounts of contamination. It has 4%, 5% of contamination, 6% of contamination. So we see that the fresh burger has much higher levels of contamination than the frozen beef burger, okay? So that basically means is that all the frozen beef burgers contamination is located in between 0 to 4% contamination, while the fresh beef burger is located from 0 to 10% of contamination. And as you can see, it has a decently high distribution. Okay, has a high amount of contaminants in the fresh one further on. Okay. The main percentage contamination for frozen burgers was 2.2%. Mark the position of the mean on the diagram above and estimate the mean percentage contamination for fresh beef burgers. Frozen was 2.2. Okay, so 2.2. Now the mean is the most common, or is the average. Okay, so the frozen one is 2.2, which is around here. So this is the mean here. Okay, mean. Now in symmetrical distributions, the mean, the mode, and the median all occupy the same point. When it's positively skewed, as in you have a lot of higher results further on, the mode stays where it is, but the mean shifts across. The mean is the most affected. It shifts further across than the mode or the median. Okay, so therefore we can just take a rough estimate away from the peak of the mode. That's where the mode is. So let's call it 4%. It's only taking a guess here, so let's call it 4%. 4%. Okay. Next question. Now, Joan owns a farm. One of the fields has a very large lake. Joan would like to know approximately the area of the lake. The lake is fenced for safety reasons. Fencing consists of 5 straight sections. There are 2 right angles contained in this fencing, which is here and here. John has walked around the perimeter of the fence and used a pedometer. A pedometer is an electronic device that counts each step a person takes by detecting the motion of a person's hips. She records the results to the nearest mirror as shown. If the shape is the 5-sided shape ABCD a regular pentagon? Explain. No, no, a regular pentagon has 5 equal sides. Okay, so no, a 5-sided regular pentagon has the same length each sides. Hence, an irregular pentagon is not regular. Okay, so basically, what we're looking to do with that is a regular pentagon has equal sides, equal lengths, and this one here doesn't have equal lengths. Okay. What's the perimeter of the shape in ABCD? So you're going to add all the lengths together. So you're going to have 12 plus 15 plus 21 plus 25 plus 28, and when you add them all together, they're going to equal 101 meters. Okay, so that's handy enough. Next part. The pedometer measures distance by counting the number of steps Joan takes. Every time she takes a step, it clicks. However, she needs to calibrate the pedometer for her own use if to measure distance correctly. So every step she takes, it clicks. So she's going to need to know the length of her average step. What piece of information does the pedometer need to know about Joan? Based on the information, explain how the pedometer measures the distance Joan walks from start to finish on journey. Pedometer must need to know the distance of each of Joan's strides. That's correct. And then explain how the pedometer measures the distance of Joan's walk from start to finish. Distance of walk equals number of steps multiplied by average stride length. Okay. Explain, do you think Joan will find an approximate area of the lake based on her measurements? Joan will get the area of all 3 triangles, which are almost identical size to the lake, hence given the approximate size area of the lake. So that's a good answer. So we're going to get the area of these 3 triangles here. Triangle A, triangle B, and triangle C. Alright. Now, explain how you think John will find an approximate ABC is a right angled triangle. One of the 3 triangles that makes up ABCDE. What's the name given to the longest side AC of the right angle? It's called the hypotenuse. Calculate the area of the triangle ABC. Because it's a right angled triangle, we can use a half base multiplied by height, which is going to be a half 15 times 25, which is the same thing as 7.5 multiplied by 25, and that's going to get you 187.5 meters squared. Okay, calculate the length of AC correct to 1 decimal place. We can use here is Pythagoras' theorem, so we want to know how long it is from A to C, so we can use Pythagoras' theorem. So this will mean x squared equals y squared plus z squared, which means x squared is equal to 15 squared plus 25 squared. X squared is equal to 225 plus 625. X squared is equal to the square root of 850. And root 850 is going to be 29.2. 29.15 and 29.15 rounds off to 29.2 because to 1 decimal place. Okay, next one. Okay, so calculate the angles BAC and BCA to the nearest degree. So the triangle we just had a second ago was BAC. Okay. So what we gotta do is we gotta find out its measurements. Okay. So we know the hypotenuse is 29.2. So it's 15 by 20. So we're just gonna make a quick diagram of this to take to the next page. So 15 and 25. 15 and 25. Okay. So 15 and 25 ABC. 15 and 25. Now, we're looking to find BAC first. Call BAC X. So let's find out what it is using SOHCAHTOA. So we can say tan X is opposite over adjacent, which is going to be 25 divided by 15. X therefore is tan inverse 25 over 15. X will therefore give me tan inverse 25 over 15. And what we're going to get is 59 degrees. Okay, so 59 degrees for this one. And if that's 59 degrees, then Y has to be 180 minus 90 minus 59. So 180 minus 90 minus 59, and we get 31 degrees. So Y equals 31 degrees. Okay. Now, next one. DEA is a right angled triangle. The second of the triangles that makes up ABCD. Find its area. Okay. So we're going to find its area. So to find its area, we got to do a half base by height because it's right angled. Okay, so it's going to be a half base multiplied by height. Okay, so we're going to go to DEA and we're going to try and find out its base and its height. DEA. Let's go back to the start. DEA. It's 18 by 12. Okay, so 18 by 12. Oh, sorry, it's 28 by 12. Excuse me, 28 by 12. So half base by height is going to be a half. So a half 12 times 28. I'm going to put that into the calculator. We're going to get 168 meters squared. Calculate AD to one decimal place. So we want to find out A to D, which is this one here. Okay. Now if to draw an accurate diagram of this, what it'd look like is this. So what's that EAD? Okay, so calculate AD. So let's call AD Y. Let's say Y squared equals 28 squared plus 12 squared. Y squared equals, just go put it right into the calculator, 28 squared plus 12 squared. And you get 928. Y equals the square root of 928. So root 928. And what we get is 30.46, which is 30.5. Okay. When calculating the area of a right angled triangle, it doesn't matter which of the two adjacent sides joined by the right angle is called the base and which is called the height. Explain. So basically what it's asked me to say there is, if I have this one here, and I say that's 8 by 6. Doesn't matter if I say a half base multiplied by height. Doesn't matter if I do a half 8 multiplied by 6, as in 8 to the base, or a half 6 multiplied by 8. Okay? So the answer is no. For a triangle, it does not. For a triangle, base times height does not depend on the choice of base. In a triangle, base times height does not depend on the choice of base. Okay. She will now find the area of the middle triangle. What type of triangle is ADC? Alright, so ADC, let's have a quick look at it. ADC, because we know the two lengths of this now. We know that this length here is we know ED AC is 30.5, and we know that AD is sorry, AC is 29.2. Excuse me. AC is 29.2 and AD is 30.5. So none of the lengths are the same, so it's a scalene triangle, okay? So it's a scalene triangle. Okay. Sketch ADC showing its measurements. Okay, so A to D, D to C, and then across here. So that's going to be A, C, D. This one here is 21. AC is 29.2. And AD is 30.5. What rule could you use to find this angle? DAC, which is theta. Alright, denote DAC by theta. Done. Write this angle in your diagram. What rule could you use to find this angle? Explain why you use this rule. Cosine rule, which is a squared equals b squared plus c squared minus 2bc cos a. Because you know 3 sides and no angles. Because you know 3 sides and no angles. Use this rule to find angle theta to 1 decimal place. Okay, so what we gotta do is this one is opposite this one, so A is opposite big A. So 21 squared equals 30.5 squared plus 29.2 squared minus 2 times 30.5 times 29.2 cos theta. Now, when I'm doing these and I'm looking for the angle, I always keep this in a box to the very end, okay? So that doesn't get done to the very end, okay? Now, quickly do this. Alright, 21 squared (441). 441 equals 30.5 squared. 930.25 plus 29.2 squared. 852.64 minus, now this part here, minus 2 30.5 29.2. minus 928.56 cos theta. Now, what we're going to do next is we're going to bring these over to one side and take them away. So we're bringing these over one side and then we're taking them away. So we're going to get 441 minus 930.25 minus 852.64 minus 1341.89. This equals minus 928.56 cos theta. Multiply both sides by minus 1. And what we can do there is we can just get rid of the minus signs. Now, just pause for 1 second. Okay, so this quick error was made there a second ago. The error was made was this one here. This is wrong. It's not a large enough number because I need a number between 0 and 1 for cos theta. So I'm just going to run that through the calculator one more time. I think I might have forgotten the 2. So 2 bracket 30.5 bracket 29.2. That's 1781.2. Okay, so that's where I just made a brief mistake. So that's 170.81.2 divided across. So cos theta ends up to be 1341.89 divided by 1781.2. Put it in. And now to separate cos and cos, separate theta, you have to say theta equals cos inverse this number here okay, and what do we get here? Cos inverse 13141.89 divided by 1781.2. Bring it across, and you get theta equals 41.11, which is 41.1 degrees. Okay, hence find the area of the triangle ADC correct to one decimal place. Now, when it's not a right angle triangle, what you have to use is the half AB sine C. Okay, now this angle here is now it's now 41.1 degrees. So to get the area of the triangle, it's simply going to be a half 30.5 29.2 multiply by, so the area is going to be all this, multiplied by sine C, which is 41.1. So we're just going to bring this all the way down. Sine 41.1. Put that into the calculator. So 1 over 2 bracket 30.5 bracket 29.2 brackets multiply by sine 41.1. Put it all in, and you get 292.73, which is the same thing as one decimal place of 292.7. Now, the true area of the lake, I had to find out what is the, calculate the approximate area of the lake to the nearest square meter. So I had to add all three triangles together. So I'm going to get 292.7. That was 292.7 was this one. the other ones. What I got for this triangle here, I got 187.5. And for this one here, I got 168. So I'm going to add all three of them together. Plus 168. Plus 187.5. Add them all together. And I get 648.2. Which is 648 meters squared. Okay. The true area of the lake measured by the survey is 610 meters. What's the percentage error in your calculation? So percentage error equals error divided by true value, multiplied by 100 over 1, which is going to be, the error is, I got 648 meters squared, so that the error is 38 meters. The true value is 610. Multiply that by 100 over 1. And what we get here is 6.3%. Or 6% to the nearest whole number. Okay, that concludes the end of this video.